Alright, well, I guess this is up so far as I can tell. Alright, and what I'm aiming to achieve here is the first episode of a podcast that I plan to start airing on Twitch every Saturday from 1 to about 3, maybe 4 o'clock. And what we're going to be going over is Snort. Snort is network intrusion software, and what that means is it's software that particularly detects if someone is actively trying to break into your network. So let's do this. Let's visit Snort. I think it's snort.org. Okay. You can run Snort on both Windows and Linux, but I am using Ubuntu 24.04. And again, okay, let's go over it real quick. What is Snort? Snort is the foremost open source intrusion prevention system in the world. Snort IPS uses a series of rules that help define malicious network activities and use those rules to find packets that match against them and generate alert for users. Okay, so let's get to my notes. Snort operates on a stack, a 4-layer stack. It operates on the data link layer, which is layer 2 of the OSI model, because Snort first decodes frame headers to determine the next protocol type. On the network layer, layer 3, Snort then decodes the IP header. This is critical for rules using IP addresses, TTL, IP options, or fragmentation. On the third layer of the stack, transport layer, which is actually layer 4 of the OSI model, Snort decodes the TCP, transport control protocol, the UDP, ICPM, ICMP, or other transport protocol headers. For TCP, Snort has a Stream 5 processor that resembles TCP streams to defend against evasion techniques like packet splitting and to provide stateful analysis. On the application layer, layers 5 to 7 of the OSI model. Finally, with the stream reassembled, Snort can decode application protocols, HTTP, DNS, FTP, SSH, etc. using dedicated preprocessors and rule options. This is where its most powerful inspection happens, looking for malware signatures and HTTP body data. Okay, so Snort is actually a collection of files. So what we're going to do is we're going to hit Control-Alt-T on my keyboard. Okay, this is the command line, but let's go back over here right quick. Okay, this is the application. This is its file structure right there, and this is a directory. This is a directory, the subdirectories of the source. Okay, now what we're going to do is, it will probably be better just to go through it in the command line. So let's open that back up. Okay, so what we're going to do is we're going to change directory. We're going to go to Snort source. Okay, now from here we want to list it out. This is the file that we're looking for right there. So we want to change directory into that. And okay, now we want to change, we list it out, and now here's something that's interesting about Linux is you see all the different colors, different text. Some is red, some is blue. We've got green, all shades of green. Okay, the blue, those are directories. We can go inside of here. These are like files. Okay, the green are binary files. That means it's an application of sorts, or with the exception of this right here. That's a text file, but it's used in applications. So let's go ahead. We need to go into the source file right here. We're going to change into the source. Now see, source is a subdirectory of the Snort. So let's go in there. Let's clear this. Okay, so let's list. What do we got? Okay, we got a lot of files. Now, in Linux, we're going to use the text editor a lot. So we're going to say nano. That's the name of our text editor. And we want to read cmake. And Linux is case sensitive, by the way. Okay. So this file, that's cmakelist.txt. It's keeping track of external libraries separately for use in package config. GCC says we must link to the threads library. Okay. It's a pretty decent file. Okay, now this means that's a comment, so it's telling us a little bit. Delegate building out the target objects like a subdirectory. List the subdirectories. So these are all our subdirectories. So no. Okay, what was the file we're looking for? Codecs. This is layer 2, layer 4 decoding. These are C++ files, and it contains the cmakelist.txt file. So let's change the directory, codecs, list it out. Now you'll notice this file right here. Let's look at it. Okay, now you'll notice that this is different than the last one that we just looked at. Okay, it's not a very big file at all. And we're not going to go over all of this just yet, but we're just going through the files real quick. So when we list it out, this right here is a C++ file. This is a header file. C++ header file. Now you'll notice the C++ files are accompanied with a header file. So we'll just go ahead and we'll look at, say, this right here, codec module. Let's say nano codec module .cc. Now the first thing it's doing here is it's calling the config.h. Okay, and it's also calling the codec module h. It's calling trace h. Okay, and then it goes into the C++. And in case you don't know, C++ is a low-level programming language, and as I go with these videos right here, we're going to be exploring it, and we're gonna do some development, and hopefully I do a better job of explaining what we're doing. But we're going to use a program in case you want to follow around. I'll open it up real quick if I can find it. Okay, here we go. This right here. This is called Qt Creator. It's free software. It's really good. It's open source, so we can add to it. We'll break down exactly what open source means, but if you want to follow along with these videos as they go, you know, you could get this, or you could use VS Code, use whatever you want. You can just use text editor. Let's close that real quick. Okay, we'll close this. Okay, so detectors, that's detection plugins, layer 3. Flow tracking, that's transport layer 4. Those are C++ files. The core framework, we got inspectors, layer 5 to 7 analysis, preprocessors. Okay, and the list goes on. If we go through some layer by layer processing pipeline, here's the exact processing order with corresponding source files. So the first thing that happens is Snort does packet acquisition, which means we're going to go ahead and acquire those packets. Thank you. So it's going to inspect the packet. It's going to take the packets before they get to you. So as soon as they come, you know, to your router, Snort's going to go ahead and grab them. But if you want to see this file, we can come over here, and we're going to back up by pressing change directory ... Okay, now we're going to change directory main. We'll list that out. What is it that we're looking for? Snort.cc, clear, nano, snort.cc. Okay, this is the very first file that's being called. 669 lines of code. Now it's calling a lot of files right here, but where's this? So let's go ahead and close that. Let's change directory to home. Okay, and we're going to say locate config.h. Now, if I'm not mistaken, it's going to be right here. So we can go ahead and we can copy that. But let's do this. Come on back down. We're going to change directory to Snort, source, clear, list. We want to copy this. Okay. Paste it in place. And enter. We're looking for source, list. Wait. Where's the tools? No. Forgot that just that quick. Alright, so this is the very first import statement. This is and the very first file of Snort that's being run. This is the very first file that's being called. So we'll get into that. So let's do this. Okay. And then we got thread. We don't need to go through all of them now. But phase 2, the layer link, or data link layer, is decoding. These files are being called, these protocols are being handled. This is where they're called from. We're going to go through some basic statements, how everything's called. Phase 3 is the network layer. Phase 4 is decoding. Takes place on the transport layer. Phase 5 is layers 5 to 7. This is analysis. These are your inspectors, these are your protocols, and these are the main files. So, and that's the complete processing pipeline code flow. And we'll get into some C++ here. This is the visual pipeline. Packet capture, data link layer, network layer, fragmentation reassembly, transport layer, application layer, detection engine. Okay, so let's go through some stuff real quick. Let's go back to our command line. What we're going to look at now is the actual Snort file as it's set up on my computer. So Snort gets installed in the etc directory. So we're going to say list it out, and we're looking for Snort. So we'll change directory. Okay. Now, since Snort is installed on my computer, it's a little bit different than what I just showed you. I guess you could say that's the back end. Really what we did is we just looked at open source software, showed you the code files, and now we're looking at how they look together. So let's go ahead and we're going to look at rules because this gets interesting. Okay, these right here are all the different ways, not all of them, but these are the most common ways that people find their way, kitty, into your computer or your phone or your tablet or whatever. One of the most popular ways that people get into your system is what's called SQL injection. So this is a rules folder right here that Snort follows to detect a SQL injection. So we're going to say nano SQL.rules. Okay, now you'll notice right off the top that there's a lot of things that are commented out, but one thing I want to go over right quick, and this is what I think is interesting. One of the things is you'll notice this is Lua script, by the way. Snort operates on Lua with two programming, or one programming language and one scripting language. The scripting language is called Lua, and you're looking at it right now, and we'll get into explaining what all this means. But what I point out to you right now, when you don't need to know anything about the language, is the message that is in every statement. You get, just look at this right here, SQL HTTP URI blind injection attempt. Okay, so that's the type of SQL injection. This one right here, format message possible buffer overflow. Okay, so that's another type of SQL injection. But these are all different types of SQL injection. So there's that many variants that people, this is a lot now. I mean, it's, if you were to try to remember every single one of these, it's a lot. This is a common SQL injection attempt, but it tells you, it'll tell you, this program, exactly what people are trying to do. Now, what I want to point out here is that we don't have a deauthentication rule, but we do have a denial of service rule. Now, deauthentication is a type of denial of service. It's a very simplified form, but this is just my opinion. I believe that there's no deauthentication rule because deauthentication packets are actually management frames. And what does that mean? So let's come over here and open recents. This is a tutorial that I'm putting together on where'd it go? strange. Okay, here we go. What exactly is a deauthentication packet? A deauthentication packet is a management frame in the IEEE 802.11 Wi-Fi protocol. Its sole purpose is to forcibly terminate an existing connection between a wireless client, like a laptop or phone, and access point. It's a kill switch sent from one party to another. It's an unauthenticated and unencrypted, even if networks use WPA2 or WPA3. This is by design in the 802.11 standard. It can be used legitimately for maintenance or administration. It can be used maliciously to disrupt the network, to handshake capture, or in an evil twin attack. The network disruption is a simple denial of service attack. The handshake capture is the most common form of deauthentication attack by forcing a client to reconnect. The attacker can then capture the four-way handshake to crack the network password. With the evil twin attack, the client is disconnected from the legitimate access point, then presented a rogue AP with the same name and steal credentials. Since the deauthentication packet is a management frame, it has different packet structure than that of the TCP/IP. Okay, so this is a tutorial that I'm writing called MAC attacks. It's things that you should know about your MAC address. Your MAC address, media access control address, is your machine's hardware address. Your MAC address is 6 bytes long and written with hexadecimal notation. Your MAC address is in the metadata of Microsoft Office projects. Your MAC address is important if an attacker is on the same network as you, at which point the attacker could launch a deauthentication attack. Okay, so that's another tutorial that we'll be going over. I wrote that, and we're going to test it on Snort. But, okay. So again, this is Lewis script. We have all kinds of rules, backdoor rules. Let's look at that real quick. Okay. I don't have anything in here, so we're gonna have to build on that. So, but